kindly you can mute the microphone. So this is our last topic for our syllabus, and you'll forgive me that I was not able to prepare the slide. I actually thought the slide is there, but I'm not able to locate the slide. So I'll just use what I have for today. Then by next week, we'll be able to complete on the topic. Hopefully, can we be able to meet on Tuesday in the afternoon instead of Wednesday? Is that okay with us?
Yes, it's okay with me.
Sister Irene. Sister Irene, can we meet on Tuesday from around 11 to 12?
It's okay.
Okay, thank you. So the last thing is about, I just hope you can see what I'm projecting. It's a Word document. Can you see that?
Yes.
Okay, thank you. Thanks for confirming. So it's about how we perform testing of our systems, how we do evaluation of the systems, and how maintenance of the systems can be done. So this is our last topic, as I've said, and it's going to be talking about those three components: how testing can be done, how evaluation can be done, and how maintenance can be done for our systems. So we need to be able to understand how we can be able to, or we need to have that understanding on, number one, system testing, how evaluation can be done for the system, and how maintenance of the systems can be done for our system. We always define that, or we always define testing as a process of checking whether the functions we have on the system are correct, or whether the software we have been able to develop is functional, or whether that software is correct. And this one will be gauged against the user requirements so that we can be able to improve the quality and reliability and quality of the system. So before we even begin creating the system, we said the first thing you shall be doing is, number one, come up with the user requirements. But at the end of the day, once you have the finished product, you need to be able to determine, is this system functional? Is it functional? Is it correct with the respect to those requirements we laid down when we are beginning the construction of the system? Just something to note that testing can be very expensive, very time consuming, but it's an activity that is worthy undertaking. There's no way you can develop a system, take that system in the market without you as the developer first confirming that that system is already functional. So that's one thing you need to understand about testing. Yes, it's very expensive, it's very time consuming, but very critical stage of system, because it's at this system, it's at this stage you determine that my system is functionally right, my system is correct with the laid down requirements that we came up during the stage number one. So we can be able to say that testing has been successful if we find that the errors, or sorry, when we are, or when you are, for us to be able to conduct a successful testing, then we need to work with the notion that this system has an error. And when you try to test the system, then you can be either be able to, or you can either be able to agree on that, or you can either be able to disagree on that. But once you test a system with the notion that this system is accurate, then you might not be, you might be able to miss that chance, or you might be able to miss the objective of why we are doing the testing. But as a developer, as the person creating the system, as the person testing the system, always work with the notion that
morning, Sharin.
Good morning, sister.
He said we did pass well the cat.
Really?
Mm.
I did not really read the notes. I used just the YouTube note that he sent, and I just studied that one.
Yeah, he showed me. I got 10. You got 14 point something.
On 30?
Hmm?
On 30?
I'm saying
Yeah.
you got 14 point something, and me I got 10.
Wow.
But I was requesting if he can give us the makeup. He said Baba he will give us the assignment.
Okay.
I
So,
think he showed us before you joined the class.
yeah.
And they said, can't you imagine even Jason is doing the course
Really?
and he has never attended this. He said, man, there's some who have been added. I saw we are around like 5.
My God. How is he doing the course when he doesn't even, God. That
Yeah,
guy,
it's
does he
not
have,
serious.
does he have a
Even I
man?
was wondering how come he's doing this object oriented, where we're doing the other hours and he's not joining the rest.
And Madam Mercy's course is not easy. You need to really understand what she's
Guy,
teaching.
that one also is not easy.
And how did this is he writing the cat?
I didn't do.
Guy. I don't know. Maybe he has a magnetic brain. Some of us we need to study and study to succeed.
But still, if you have not done even the cards,
Yeah. For me, he would have better left, or maybe he just attending.
he has never attended the class. He doesn't have even the notes, I guess, because he's giving you the notes. If you and me have not given him,
Yeah. I don't know. Maybe that guy is having a magnetic brain. You don't know. You can never define someone. Yeah.
and
So
Sorry, we had lost power in our canvas.
it's okay.
Yeah, can you proceed?
yes, sir.
Okay. So I think I don't know why we even lost the power, but we said for testing to be very successful, you have to have the notion that you want to make your program fail. And once you work in that notion, that the notion of this testing will be to make your project fail or your system fail, then you can be able to get the errors, you can be able to identify the errors within the program. So the main intention of testing of systems, you want to be able to create more strong systems, and your main focus should be on what are the weak areas of the system. If you can be able to identify the weak areas, for example, you can invite someone, then you try to tell them, try to hack to the system. If the people are able to hack in the system, then it means your system has some kind of a weakness in terms of security. You can even maybe try to ask maybe someone else to do something on the system, and if at all they are able to do something that's not expected of them, then it means that your system has a challenge with respect to security. So try to identify the weak areas of the system so that once you get the feedback from the testing, then you can be able to incorporate that feedback again and try to make your system to be more strong. So we look at the stage of testing the system, and step number 1 is about coming up with the test strategy. And this is simply like a statement about what levels of testing are we going to be working on. Maybe we will do a testing for the student, we shall do testing for the lecturers, we shall also do testing for those people in management. The different methods, the different tools and techniques that shall be used for testing will also be identified in stage number 1. And this one should be closely tied to the needs of that organization. Once you have been able to come up with the strategy, then you can now be able to go ahead and come up with a plan. And this one, it's supposed to be able to verify that the system being tested fulfill a certain design and functional specification. Some of the information you can be able to include in the plan will include what are our objectives of testing for each phase. If let's say I'm going to be testing for management, what are we testing for? If I'm doing testing for the student, what kind of testing are we doing at that level? It's also going to involve the approach and tool to be used for testing. If let's say you are going to use a questionnaire, then you are going to be very clear that once the system has been developed, then we shall be able to give them the users the system, then give them a questionnaire to be able to fill. So the approach and the tool to be used for testing also need to be very clear in the test plan. The responsibility and time required for each testing activity also need to be very well outlined in your testing plan, because you need to be able to know who shall be doing what in terms of testing and what activity are we going to be doing in each of that particular activity. Then we look at the availability of the tools, facilities, and the test libraries. If let's say it's a software, then you need to be able to see the tools I've said I'm going to be using, are they available? Are the facilities available? If you are using a certain library and you have some kind of data you want to get from that library, then do they have the enough data I need to be able to test my system? We also look at the procedures and standards required for planning and conducting the testing, and also what factors are we going to consider for us to be able to gauge that the testing was successful, because those indicators need to be very clear. Otherwise, you are going to start testing something, but you are not able to tell, are we able to know that testing was successful or not? Then step number 3, it's about coming up with a test case design. The test case design will be used to cover the main errors as possible in the system. For example, you can come up with a case, try to tell the user to log in. If the user are not able to log in, what did you observe? If let's say you tell the user to create an account, are they successful? If they're not successful, if let's say you say, after creating the account, the system should send the user an email. Is the system able to do so? If that's not the case, then that should be well documented in your test case design. And we can be able to identify a number of test cases for each module for the system to be tested in a proper way. Each of that case will be able to define and specify how the implementation of the requirement design is to be tested, as well as what criteria will we able to use so that we can determine that testing was successful or not. The testing plan and the testing case will be well documented as part of the system documentation, and that's what we call the test specification or the text description document. So those two documents, the test case and the test description, they need to be put very well in a document so that when we start testing the system, we know exactly what are we testing and what is our expected output from this. If let's say we have a case for creating an account, I know, for example, from that, the customer should be able to create an account, number one. The customer should be able to get a confirmation that the account was created either via email or via other mechanism. But if the system doesn't do so, then it means there's something wrong in our system. So we look at the step number 4, it's the test procedure. And this one will be able to tell us the procedure, all those steps that we are going to follow when we are executing the test case in stage number 4. So these are very specific steps for you to be able to test a test case, for example, the one for registration. Then we shall do 1, 2, 3. So it's a very detailed plan procedure, and this one will also be contained on a separate document known as REST procedure specification. The document will also contain special requirements and formats for reporting of the result testing. So this is going to be a very detailed document. I just wish I had a sample, but it's very detailed in such a way, it's going to tell you, for you to test for this plan, then this one will be the procedure. This one will be the expected output. Do we have some kind of special requirements that have to be considered? I hope maybe next week, if I can get a sample test procedure, sample document, and a test case, I can bring them to you so that you can see how they look like. The stage number 5 will be the test result document. And this one will be able just to contain what or which of the test cases were executed, what were the errors on those test cases, what was the rate of success on those test cases. Then we can now be able to assess the results against a certain criteria for us to be able to determine the outcome of the test. Was it successful or was it not successful? So in the next few minutes, I want just look at all, I want to take you through the software testing techniques. So we can be able to say that a certain technique is debugging oriented technique. And in this case, we are trying to, so it's a technique, sorry, it's a technique that will be able to work in such a way that we want to be able to find the errors in our program. So if a technique is engineered in such a way that the main aim of that technique is to identify the errors within the system, then we call that one a debugging oriented technique. We can also have what we call the demonstration oriented technique. This one, number 2. And this one is geared at showing that the system is working. So if you are able to do some form of testing, and the rationale behind that testing is you want to be able to show the user that the system is working as expected, then that's what we call the demonstration oriented technique. The distraction oriented technique is the opposite of the demonstration oriented technique. It's supposed to show us that the system is not working. So it's like we are trying to test the system so that you can be able to show the user or the person that this system is not working as expected. And it's also very important, when you are testing system, don't just test the system to show someone that this system is working as expected. Try to see, could this system which you are proposing, could it also be, we have a case that the system is not working as expected. And that's what we are calling, that's what we are calling the distraction-oriented technique. Then we do have the evaluation-oriented technique. And this one, we want to be able to evaluate the system. And we do have a certain requirement, which we want maybe to be able to assess how is that certain requirement being implemented within the system. So if you can be able to do testing in a manner that you can be able to you can be able to show how a certain feature it's been implemented within the system, then we do call that one evaluation oriented technique type of testing. And the last one is what we are calling the prevention oriented technique. And this is a technique maybe whereby you are trying to test the system, but maybe you have an illusion maybe of a certain error that can occur in the system, and you want to be able to prevent that error from happening. For example, let's say, can I say, for example, you have this kind of or you have a feature for login, and you want to be able to, or you want to be able to test such that in such a way that if, let's say, I try to log in as a student, I cannot be able to see the features of admin. So this is this is going to be a type of testing whereby you want to be able to show that the user, a certain user, cannot be able to do certain tasks within the system. It's like prevention-oriented technique. So all these techniques, all these types of techniques are supposed to be able to, are supposed to forecast, or are supposed to tell us in advance the possible errors, so that you as the designer can be able to rectify those errors within your system. And I think we can be able to start with testing strategies, all types of testing, on Tuesday at exactly 11 to 2. Any questions before we call it a class? Charlene, I do have a class starting exactly at 11, so I want us to end the class at that point, but we shall be having a class on Tuesday from 11 to 2. Any questions?
So what if we make it from 11:30?
11:30 is still okay with me, no problem.
Okay.
Yes, because my Tuesday class ends at 11.
Okay.
Yes, Charlene.
I wanted to ask on that the chain notation.
Yes.
I want you can
Yeah,
see how.
there's something I said. I think either you are not there when we are starting. I said that part of the data, that part of the design, there are two things you never did: the data flow diagram and the database design. I'll come back to it on Tuesday once I've done the chapter 6.
Okay, sir.
Yes, I'll come back to that part. So we can have a blessed day. Let's meet on Tuesday exactly 11:30. God bless you.
Okay, thank you. Have a nice day too.
Okay, you too.
Okay, thank you too.
Okay, thank you.